The other ones you just have to clean up a little bit. But the process is basically the same. So everybody was good for this? Okay, the back solves are nice, but you're going to use this again. And this one was okay? Concept of solving backwards. Find your one variable, plug it into something that has two, plug it into something that has three. Okay, how did this one work? Be honest with me. How many of you didn't get this one? Okay, I'll be glad to do this one. Now, your goal here is this. See this one that doesn't have a Y? And this one's going to help you out too. See how it doesn't have a Y? Here, what is going on? Every day is something different.
Looking for you to type.
Am I smart and
Just press the button.
Have a little cursor on the left side.
Hang on. Alright, so look. We've already got something that has an X and a Z. So your goal now is to take these two and eliminate which one? The Y. Because I want to have something that has an X and a Z. So I come over here and I notice that if I add them down, won't I eliminate the Y? So this is my A. Oh, my whole board is off. So now I may have no Y in this one, no Y in this one. I have two equations with two variables. So I can take those two equations and combine them again to eliminate one more variable. Doesn't matter which one. I tend to go with the ones that have like the positives and negatives. That works usually for me better if I have a positive and negative and I don't have to multiply by a negative. I tend to lose my negatives. But if whatever one you would like to get rid of, you both have 3x and 3x. You can multiply 1 by a negative 1. That works too. When you get to your one variable, you're going to back solve, so it doesn't matter where you go. I just chose to eliminate the z. So I multiplied every term by 2. Still having to multiply this side, but this side came to a 0. Now combine your terms. This will eliminate. Now I solve for one variable. At this point, I back solve. I go to something that had only 2. Most of the time you go back up to one of these original ones in here. It just so happened that one of your original ones is probably the better one to go to, because that we didn't change at all. So we go back up to this guy, plug in your x. I plugged in the x. I found the z. Back solve again. Now go to one of them that has all 3. Because you have 2 covered, you only have to find one more, the y. Once you find them, that's your triple. Put it in the x, y, z. Okay? I'll walk through the next one from start to finish. So this way we walk through one of them. Let me see if I can get a blank page here. Alright, let's walk through this. Label them 1, 2, 3, so that we both know what we're talking about here. Do I have them right? I'm going to go through the whole thing and miss a sign here. All right, now, eyeball them. Okay, pick a variable that you'd like to get rid of first. Y. Why did you pick Y? A 4 positive and a negative 4 were right staring us in the face. Agree? So we're going to take 1 and 2. And could I still go for the x's? Because I like the fact that I get rid of x first. Can I do the x's anyway? Can I do the z's? Yeah. Maybe I like to go backwards and always just pick a z, then a y, then an x. It doesn't really matter. So you're going to take these two and line the other one up. This is my 1 and 2. When I add them together, out comes the y's. This I'm going to call A. Okay? Now I got to pick another 2 and eliminate the same variable, because I'm going to come up with 2 equations with 2 variables. So pick another pair. 1 and 3. And you picked 1 and 3 because they're different signs. That makes life easier. Why have to multiply by a negative if you don't have to? But I notice that if I add these down, my y's are not going to cancel. So Justin, what could I multiply the bottom one by to make the y's cancel out? Not a negative, just 2. Good. So we're going to multiply this guy by 2. We're going to get 8x minus 4y plus 2z all the way across. Okay. Bring this one back down. We didn't change this, just bring it back down so we can add it together. So out comes the y's. I've got 10x plus 3z equals 8. This is b. Now I'm going to combine a and b because they both 2 equations, 2 variables. So I bring this up over here and I say, if I add these down, nothing's going to eliminate. So I look at my coefficients. I notice they're both positive, so that doesn't ring a bell. So I have to multiply, obviously I'm going to multiply both lines. Which one would you like to eliminate? Raven, which one would you like to eliminate? Okay, so now, you're going to find the first common multiple that 4 and 10 fit into. Take the 10. Okay, so normally we say 4 doesn't fit into 10, we double it, 20. What do I have to multiply the 4 by to give me 20? What do I have to multiply the 10 by to give me 20? One of them has to be a negative. Which one would you like to be negative? So I'm going to go with this one, okay? The 2, the 10, right? All right, so let's pull down the front, the first one. 20x multiplied all the way across plus 35z equals 45. Multiply through the second one. Negative 20x minus 6z equals negative 16. Oh, we eliminated x. So I'm left with 29z is equal to 29. So therefore, z is equal to what? 1. Now your goal is to find x, y, and z. So now, back substitute. That's a little bit long, but now you want to go to one of them that has 2. Obviously, none of our original has 2. So go back to one of these, A or B. Which one would you like to use? A or B? To substitute Z into. B. So we'll take B because it only has 2 variables. We can't go into 3 yet. We're back substituting. So we'll take B. We'll substitute Z as 1. So 10x plus 3. We subtract 3. The divide by 10. X is equal to 1 half. Now, I'm back solving. I have 2 solved. I go to one that has 3. I can go to any of these, any of them. Which one would you like to go to? The first one. So I'm going to just do it right up here. I'm substituting in the x. I don't know my y. I'm substituting in my z. And I'm going to solve. This gives, what? Oh, -4. Thank you. This gives me a 1 plus 1 is 2. Oops. I worked a little lot. Minus 2. So that'll give me -6. So 4y is equal to -6. Divide by 4. And I'm going to reduce it to -3 halves. Now, since those are so weird looking, I could go to one of the other ones, plug it in, and just make sure that it checks. Ideally, you could go to both of them. Make sure it checks. When we come back from the break, we're going to make a matrix. And check it on the matrix. Yes, Chris? Oh, check. So, your goal is to take 2 equations, combine them to eliminate one variable.
See, I wasn't using the same variable.
Neither was Ray. So you were stuck. You don't
I
use
do
the
the
same.
first step and then I just forget.
Right. What happens is if you don't eliminate no solution because you think you do something wrong, but this one was a no solution because you can have systems of equations that don't work. Yes.
So, like, for this one, the first thing I did was I used the first and second equation,
Okay.
and I multiplied it by 2, so the y and the z cancel out, so could you do that?
Absolutely. So let's do yours. Because you really meant to eliminate one. You just didn't know that the other one was going to eliminate. Which one did you need to eliminate? You were probably going for the y's, right? So you multiplied this by 2. So we're combining these and these. This is coming out, and coincidentally that guy's coming out. And it's going to be equal to 7. Oh, 5x. Sorry. 5x, and it was going to be equal to 7. Now, you said, okay, I got to go to 2 more. Which other 2 did you use? Okay, so now, we can do the first and third, or we can do the second and third. 2 and 3. I would rather not do, because my goal is to eliminate y at least. If I go to the first and third, there's 2 different ones. One's going to be need to multiply by 3, one's going to be need to multiply by -2. So I'll go to this one, the 2 and 3, because at least my signs are there, and I only have to multiply one of them by 3. So I take this one and this one, which I did somewhere, which I did right here. I multiplied the top by 3, and coincidentally, my y and my z canceled out again. But now, my 5x was equal to 17. So can 5x be equal to 17 and also equal to 7? No. So that's why I know I have no solution. You can't have your x be 2 different values. So this tells me no solution. And it happens. You have systems of equations, you have 2 lines that are parallel, they never cross. You'll have 3 that will not intersect you. You have more to lose with 3. And this is the last one. This one was probably like the most work. Because, first of all the signs were the same. Most of them you had to multiply by 2 different things. There was not one that was going to cancel out nicely. So pick any 2. I picked to eliminate x because I saw the 2 3x's. So I thought, okay, that's the only ones that I really see in common. So I went for that one. I multiplied 1 by a negative, and I'm left with my y's and my z's. So go back to your original, pick any other 2, and eliminate x again. The other ones took a little bit more work to eliminate. And your coefficients were really tough on this one. Coefficients were harder. and they were all positives. When you come to the end, and if you check this and it doesn't work, when you work backwards, how you work this way, work yourself backwards again. Look at the last one you substituted in, then go back, then go to these guys, then go back. Most of the time, here's where the problem is going to be, right in here. Well, these were zeros because they were nice. But sometimes when you go and you multiply all the way across, you forget the other side of the equal sign. Most of the time it's there, or it's a negative sign. Or you know what else is a tough one? You're rewriting these so many times. If you rewrite them incorrectly, that is one of the hardest ones to catch, unless someone looks at it for you and sees it. Because you know you took that one. Oh, I rewrote this one, it's right here. But you didn't bother to check that you had all the signs right. The signs are what usually, I copy them down fast, and then I miss a sign, and then everything is totally off. So we're feeling a little better about this? Raven, Justin, feeling a little better? Chris? Good, Elijah? Alright. Alright, the let statements. Now, I tend to use X and Y and Z. If you choose to use letters, that's fine. My thing is to kind of keep them in alphabetical order when you give me a solution. So we have a candy recipe which calls for 2.25 times as much brown sugar as white sugar. So first of all, who uses more? Brown sugar or white sugar? Brown sugar is using more. So generally you let X be the easier one. Let X equal the white sugar, or it doesn't really matter which one you let X be, and let Y, and I know you could do it the other way, but let Y equal the brown sugar. Does it matter which one we do? No. Because with your let statements, I'll be able to see when you write your solution like this, I'll know that your X is the white and your brown is the Y. Now, you can use whatever you like. I just tend to use X and Y.
Okay.
And the last class I solved this the opposite way. Brown was my X, Y was my white. So, just so that you realize like there's no special pattern. Now, here's your goal. You have two variables. You have to get two statements out of this. So we know that the brown is 2.25 times as much as the white. And the next part they told us was if 23 ounces of sugar are required, how much of each type is needed. So see if you can get me a statement out of here. Build me an equation. Build me two equations from the information that's given to you. Does this one help? $23 ounces altogether of sugar. It means by the time I put in my brown and by the time I put in my sugar, 23 ounces of sugar is there. So the brown plus the white is equal to 23 ounces, right? What's my variables? And there's one statement, right? And my brown has 2.25 times as much as the white. My brown is the Y. It's whatever my white has times 2.25% more, right? 2.25 more. There's my second statement. And save yourself, which one's going to get more? If my white has 1 pound, isn't my brown sugar going to have 2.25 pounds? And isn't that what I wanted? Always look at your statement in words afterwards, because if you write it backwards, you will see that your white had more than your brown.
So I think
25x. But because I just wanted to use two variables right now. Because the rest, when we do this, we'll have 2 and 3 variables. It won't be as easy as this one. I just wanted to keep the 2 variables, and yes, I could even write plus x. I could have wrote 2.25x plus x. So now how we're going to do it is exactly the way Rebecca said. We're going to substitute. We're going to take out this y, and we're going to substitute in this. Could you have done that right off the bat? Yeah, but I just wanted to stick with two variables. So we're going to get 2.25 x plus x equals 23. Now we're going to solve. 3.25x is equal to 23, and we're going to divide by 3.25. Rule of thumb, we'll still go 3 decimals. 7.077, this will be, should be pounds, ounces, should be ounces. Ooh, put so many pounds in there, right? So now, bring this back up and substitute this back in here and find out what your brown sugar is. That's got to have more, right? Brown has to come out to be more than the white. That will give us 15.923 ounces. So if I do my x and my y, I get 7.077 and 15.923. And if you eyeball this, even if you multiply the 7 by 2, isn't that 14? And then I have to have a little more because it's 0.25. Makes sense? If I add these up, will I come up to 23? Just about. We have a little rounding in there. So if it comes out to 22.999 or 23.001, we're okay. We round it. If you want to leave them as a fraction, that's probably better. I know how you hate fractions. So are we okay with this? Okay. Now the next type of problem requires a little bit of thinking. This is an investment problem. So now before we do this, let's just talk about how we invest money. I gave you guys $300 to invest. And I have all these accounts you can invest in. And some give you 5% on your money, some give you 7% on your money, some give you 10% on your money. You would love to put it all in the 10%, but it all comes with a risk factor. You may lose your money a little. You know, if the market in there drops a little bit, you may not get your 10% back. So that's why people don't put all their money into the highest interest one. Or it may be that that sits in there a little longer, or whatever the case may be. The rule is you invest a certain amount with your interest, and that's what you get back from what you invested. Okay, so now, we're going to have a total. How many of you have economics right now? Or have? Had or have, right? So you've invested money in, you know, stock market, bonds, things like that, right? So you know what your return comes back. I always find this a little tougher because usually, you know, at your ages, you don't really, I don't even have this money to invest, but you know, you don't really make these investments. So we have a total, oh my goodness. We have a total of 1,520 a year is received from the interest that I earned. In other words, the money that I put in there, I got back, say, 7%. That's interest. All the interest that I collected from my account add up to 1,520 a year. The interest rates are 5%, 7%, and 8%. So we're going to let X be the amount invested at 5%. We're going to let Y be the amount invested at 7%. We're going to let Z be the amount invested at 8%. We don't know what each amount is, but we do know that the interest received adds up to 1,520. Now, for instance, if I invested $100 at 5%, how do you figure out my interest? Times it times 0.05. So if, for instance, I invested 100 at 0.05, Robert says just multiply these. you'll find my interest. 10% would have been $10, so half of that is $5. I got $5 back. These are yearly. So I got $5 back at the end of the year. So now, my total interest from all these accounts, that means my X amount at 0.05, my Y amount at 0.07, and my Z amount at 0.08 will add up to 1520. This is how much interest I am going to collect on my accounts. Okay, we just looked at a simple invest 100, multiply it by 0.05. Our problem is we don't know how much was invested at 5, 7, at 8. But the interest total will add up to 1520 a year. So now we look for another statement. The 5% investment is half of the 7% investment, and the 7% investment is $1,500 less than the 8% investment. Now, what I find easier is to go back up here. The 5% is your X. 7% is your Y. Y and Z. Put the letters up there. So I want to say the 5% investment is half. So whatever I invested at 5% is half of the 7%, which is my Y. Agree? Pull the words right out. Now, if you don't like to look at this, you can multiply it by 2 and replace the X. Let's see what we're going to replace at the end first. My third statement says the 7% investment, Y, is 1,500 less than Z. So how do I write that? Good. Z minus 1,500. Now, I've got 3 variables, 3 equations. I can very nicely slide this in for Y into Z. I can do that one. Okay. I can take Y out of there, make it in terms of Z. Do I have a way to get X out in terms of Z?
Because the y in the 1/2.
Okay, Y in 1/2, we can play with that, but do I have anywhere to get the X out in terms of Z? I got to see which ones I can replace and which ones I can keep.
Yeah, that's what I'm saying.
You make it 2x equals Y. This is the same as 2x equals Y, isn't it? Oh, and can I make this one be in terms of Y also? Can I solve for Y there? Can I get the Z out in terms of Y? Okay, if you want to get them all out together the same way, you got one equation that you can go back to. So either one of these is going to work for us. And let's do this one a little bit differently. Take a look at that. See what you can come up with. I can replace the Z in terms of Y. I can leave the Y there. Can I replace the X in terms of Y? Yeah, I can replace the X in terms of Y. So I have to figure out which one I want to replace. Chances are you want to replace it that way. Now, if I bring this all out and replace everything in terms of Y, this guy's going to come out. My X is now 1/2 Y. Let's just write this out. My Y stays the same. My Z, we might have to do this tomorrow, but my Z is this. This is all equal to 1520. So, in terms of Y, let's get everything in terms of Y. The only thing we could go with. We couldn't take the Y out and put a Z in there because we had no way to get the X out there unless we did the Y first and then the Z again, and that's annoying. You wanted to put this Z in place of that Y? That's a hard one to do. Now, all you got to do is distribute here, collect your like terms, and solve for Y. And back substitute. Stick the Y in here, find Z. Stick the Y in here, find X. We'll finish this one tomorrow. But tonight, guys, if you do, I'll give you the problems. Do number 2, do number 2, number 4, and number 6. 2, 4, and 6. And 7. 2, 4, 6, and 7. I'll do the investments tomorrow. Because they're a little bit